Now see here alpha decay, already we have discussed about the alpha, beta and gamma decay, but now we will be discussing in detail here actually. So in alpha decay, suppose you have taken, first thing is here alpha particle is assumed to be the nucleus of helium, that is here 2He4. So the nucleus of the helium is taken as alpha particle. Now if you have taken any element Z, here X and A, this is called a parent nucleus, and this when disintegrate and produces alpha particle, that is 2He4, new element is formed, because that is a new, because here the 2 and 4 has gone to this side here. So whatever the new nucleus is formed, that is called a daughter nucleus, and daughter nucleus has got atomic number reduced by 2, less by 2, and mass number is less by 4. So this is actually alpha decay. But see here in this process energy is released, that is we take it as a Q. So we can calculate Q here. Q is equal to, for calculating Q first we need to calculate mass defect. So we can calculate delta M is equal to mx minus my plus m alpha. This is your mass defect. So total mass of the parent nucleus minus mass of the products. This is called mass defect. So this mass defect can be written here, delta M is equal to mx minus my minus m alpha. Then we can calculate energy, that is E, we can take here as a Q, because I have written here the Q. Q is equal to delta mc square. So here Q is equal to mx minus my minus m alpha into c square. So this is the energy released in this process. Now take care here, if initially x is at rest, suppose you are writing here initially, if x is at rest, if x is at rest initially, then Q is completely here shared by these two products. So that is the kinetic energy of these two products is equal to here Q, and Q should be, or that is greater than 0 if it is here, this is x is at rest, and this is here the positive energy, that means the reaction is exothermic, energy is released. So here the kinetic energy of the products, basically the kinetic energy of alpha particle can be calculated from this concept here.